Hello again, Year 10. This is the second lesson in the GCSE Forces and Balance topic, the effects of resultant forces, and you'll find the backup information on the relevant pages that you can see above there. Today, you should be able to recall that the resultant force on a body is produced by adding together all of the forces acting on that body. Sounds complicated, it's not really. Be able to calculate the resultant force of two forces when they act along the same line, or collinear. Recall the effects that resultant force has on the motion of a stationary body, and recall the effects that a resultant force has on the motion of a body that's already moving at constant speed. Before we get into that, a quick little quiz based on the work that we did last lesson on contact and non-contact forces. You might like to pause the video at this point and then answer the questions above. No need to write anything down. You could put T or you could put scalar or vector, contact or non-contact, briefly by the list of quantities that you've got there. Okay, pause the video now. Okay, so scalar or vector quantities. Scalar quantities just have size, no direction. Vector quantities have size and direction. So temperature is a scalar quantity. Force is a vector quantity. All forces have size and direction. Weight is a force, so it is a vector. Area, scalar. Velocity is the speed in a given direction, so that is a vector quantity. Contact, non-contact forces. Weight is a non-contact, it's a force of gravity acting on a body. Air resistance is a force whereby the air has to be in contact with the moving body, so that's contact. Likewise, friction. Likewise, tension, and electrostatic or static is a non-contact force. Hope you got those. Okay, we're now going to look at resultant forces, what they are and how we can work them out. In the red side here, guys, for your notes means you have to have this slide printed off or written down in some form. Okay, so when forces are acting in the same or opposite directions, you can add them together to find the resultant force. The resultant force is quite simply a single force that can replace all the other forces that are acting on that body. It sounds complicated, it's not. Let's take a simple example whereby we've got a tug of war team here. Tug of war team A are pulling to the left, tug of war team B pulling to the right. A are pulling with a force of 500 newtons, B with a force of 450 newtons. Well, common sense would tell us that Team A are going to win. How much are they going to win by? They're going to win by a force of 50 newtons. 50 newtons, and that would be the size of the resultant force, the result of adding those two forces together. Now you might be thinking that 500 plus 450 makes 950. Adding them together doesn't seem to make sense. Well, you've got to take into account their directions. So you could say that that's pulling in a positive direction, so that'd be plus 500. That's pulling in a negative direction, minus 450. So add them together, plus 450 plus minus 450 gives us 50 newtons, plus 50 newtons in a direction to the left. Okay, so that single force has now replaced the two forces there. Okay, resultant forces replaces all other forces acting on that body. Okay, so what are the effects of these resultant forces then? So if the resultant force is 0, in other words, the two teams here were pulling with the same size force but in opposite directions, so when you add them together you get 0, it would have no effect on the motion of the body. That's really important. So if the marker here was stationary to begin with and the forces are balanced, the old key stage 3 term we used, the resultant force is 0, then that marker would stay there. It would not move. If it's already moving to the right, for example, at a nice steady speed, it would continue to move at a steady speed. A resultant force is 0, there will be no effect on the motion of the body. If the resultant force, however, is not 0, the body will accelerate in the direction of the resultant force. pause the video so that you can get that note down. Okay, let's look a little bit more closely by what we mean by resultant force, giving you a specific example. Okay, consider these four mini cars here. Each mini car has different forces acting upon it. If we look at the first one here, the first one has a single force which is directed from left to right. What you have to say in the box here is what will happen to that car if initially it is stationary. Okay, now I would hope that that's fairly straightforward. We've got a resultant force going from left to right. If there's a resultant force, then the object will accelerate in the direction of that force from left to right. So quite simply, it'll move off in a direction left to right. But this key term here, accelerate, it will increase its speed, is important. If it's already travelling at a constant speed and that resultant force acts on it, again, it will accelerate from left to right. So imagine if it's going at 30 miles an hour, it will accelerate to 40 or 50 or whatever. The second example here, the resultant force is smaller because you've got the same size forward force going from left to right, but another force acting right to left, which is going to try and counteract that. So when we add a positive force to a negative force, we're going to get a slightly smaller resultant force, which means the acceleration will be slightly smaller, but again in the direction of the resultant force, left to right. And similarly with the car moving initially at a constant speed. The third diagram here is meant to show two forces which are equal in size but opposite in direction. Now if you add those together, the resultant force will be zero, just like with the tug of war team, which are balanced. So remember, if the resultant force is zero, it won't affect the motion of the body. So if the car is stationary to begin with, it'll remain stationary. And likewise, if it's travelling at a constant speed, it will continue to travel at a constant or uniform speed. That word uniform means the same. The bottom mini has one force acting from right to left, so there is a resultant force acting on it. Its motion will change. So if it's already stationary, it will accelerate from right to left. It'll move backwards, in other words. The next bit is slightly trickier. If it's already moving at a constant speed left to right, so it's already moving forward, and a resultant force in the opposite direction acts, that will cause it to accelerate or decelerate, this time from right to left. So it will cause it to slow it down. Okay. Normally you'd have a worksheet to go with that activity. If you wanted to sketch that down or not jot down the results, that's entirely up to you, but make sure you know the key ideas. Okay, so what you should have learnt from all this then, you should know that a single resultant force can replace all forces acting at a point. Okay, now normally at GCSE we'll be talking about two forces. What is the resultant of those two forces? Okay. You should be able to calculate the result of two forces acting along the same line. So, for example, the tug of war teams that we saw a few moments ago. You should be able to recall that the resultant force of zero has no effect on a moving or stationary body. So if there's zero resultant force, it will continue remaining still, or it will continue moving at a steady speed. And finally, if there is a resultant force greater than zero, that will either cause a change in velocity and acceleration, and or a change in the direction of a moving or stationary body. A resultant force will affect the motion of a body.